last example for section 6.6. This is a much more complicated exponential equation, and like I said on the last example, there were two ways to solve it. One was just converting to a logarithm, and one was taking the log of both sides. Obviously on that one, taking the log of both sides was much more complicated, but got us to the same answer. However, on a problem like this, the conversion is difficult because you have two exponentials, not one, and getting them together to be one is difficult if you don't have the same base. And so really taking the log of both sides is the best option for one of these more complicated exponential equations. So that's what I'm going to do, is I'm going to take the log of both sides. I'm going to use the common log again, just because that's the one I like to use. But you could use natural log or really any base you want. So I'm going to take common log of the left equals the common log of the right. And remember, you can do this because the logarithm is a one-to-one function. Okay, now property number 9, remember, tells me that the exponent in an argument can come out as a coefficient. Here I have two complicated exponents, but they can come out as coefficients to the logs. Alright, so now I have x plus 1 on the outside multiplying the log of 2. And here I have 1 minus 2x on the outside multiplying the log of 5. And it's going to be very important to put parentheses around those exponents, because in my next step I'm going to distribute through the log of 2. So distribute the log of 2, I get x times the log of 2 plus the log of 2. Right, 1 times the log of 2. On the other side, I distribute through the log of 5. Now, log of 5 and log of 2 are just a number. They're a decimal, some sort of decimal. So I can treat them just like any number, distribute with them, combine like terms with them, and so forth. So here I get log of 5 minus 2x times log of 5. All right, at this point, just like any other equation, this looks like a really complicated equation, but the x's are linear, they're raised to the 1 power, and all these logs are just numbers, they're just a constant. And so this is just like any other linear equation. You got to get the x's on the same side, get the constants, the terms with no x, on the other side. So I'm going to eliminate the x term from this side by adding it to both sides of this equation. Okay, it zeroes out on the right, and on the left I'm going to keep them. Notice the logs are different, so I can't just combine these as like terms. So it's going to be x times log 2 plus 2x times log 5. Okay, so that's two terms. I still have my log of 2, and that's all equal to log of 5. Now I want to get my constant term to the other side, so I'm going to subtract log 2 from both sides, and again I cannot combine the two logs.